What do you think of when someone mentions the Arctic? Maybe you visualize brutal blizzards and piles upon piles of snow. Or perhaps you are reminded of wildlife like penguins and polar bears. Regardless, you probably don't associate this region with fires. The burning of the Boreal forest paints a very different picture than the one described above. Boreal forests are vital parts of the geosphere's carbon cycle. The climate of these regions means that they store carbon differently than other forests. When trees and other organic matter die, they fall to the forest floor. In a typical ecosystem, which is relatively warm and dry, decomposers can easily break down this organic material and respirate it back into the atmosphere. In the Boreal forest, however, this is not the case. Cold and wet environments found here severely limit how quickly the decomposers can do their job. Lots of organic matter remains in the soil as a result. Michelle Mack, a professor at Northern Arizona University, explains this concept quite well, saying that carbon accumulates in these soils like tree rings, with the newest carbon at the surface and the oldest carbon at the bottom. Organic matter that does not get decomposed eventually gets covered by other dead materials, creating many carbon-rich soil layers. Layers of carbon that are deep within the soil are referred to as legacy carbon. The Boreal forests are considered carbon sinks. That is, they intake more carbon than they return to the atmosphere. NASA says they host about 30 to 40% of Earth's land carbon, making them some of the world's largest sinks. However, the balance of carbon transfer is being threatened by an increase in intensity and frequency of wildfire. Anthropogenic climate change has made the Boreal forest hotter and drier, which makes the vegetation there more likely to catch fire. Dryness also means that fires will burn much hotter. Some estimates, like one from Woods Hole Research Center, believe that the result of this is a 130% to 350% increase in the total forest area burned by mid-century. The massive amounts of carbon released in this process could mean that the forests will start to emit more carbon than they store, making the forest a carbon source. New research from NASA's Arctic Boreal Vulnerability Experiment quantifies the amounts of legacy carbon burned in recent fires. 2014 marked a historic year in terms of the wildfire intensity, so the opportunity was taken to monitor the amplified burns. The team used soil radiocarbon dating to determine the effects of wildfires on 211 plots of burned area in Canada's Northwest Territories. Ultimately, they found that in the younger areas of the region, less than 60 years old, and the drier parts, significant amounts of legacy carbon had been combusted. As for the older and wetter parts, significantly less legacy carbon was affected. The implications of these findings provide a clear warning for the future. As it stands now, the legacy carbon closer to the surface is being burned, but as climate change continues, landscapes will only continue to get hotter and drier. When fires burn more intensely and don't give landscapes time to regenerate, deeper soil will be infiltrated, and the amount of legacy carbon released will increase greatly. Seen here is an incredibly powerful feedback loop, but one that is not always adequately recognized. After all, people do not usually associate the Arctic with deadly fires. However, awareness must be spread, and measures must be taken to trim forests and to further insulate legacy carbon. Otherwise, the carbon bomb that unearth.org says lies under the soil will no doubt detonate.